Something just happened in our solar system, something that shouldn't be possible. An object from another star system just exploded with light near our sun, and no one can explain why. Psalm, on October 29th, 20. As the interstellar traveler known as 3I Atlas swept past the inner orbit of Mercury. Every comet brightens as it nears the sun, a slow, predictable crescendo as frozen ices turn to vapor. But 3I Atlas didn't brighten gradually. It erupted. Within hours, its luminosity spiked by more than a factor of 2. Telescopes across the world, from the Lulin Observatory in Taiwan to NASA's SOHO satellite, recorded a sudden, violent flare. At first, scientists thought it was a data glitch. It wasn't. The object had truly detonated with light. Spectral analysis revealed an intense blue shade, more luminous than sunlight itself, a clear signature of carbon, and, in 2 short weeks, the comet's outgassing increased by a staggering ratio, 5.7 times, 10 to the power of 28, water molecules every second. That's 40 times more than it had been losing just 1 month earlier. One astronomer described it as a frozen geyser turned into a fire hose. And yet, something about the timing felt wrong. The outburst didn't begin as Atlas approached the Sunday. It waited until the very instant of perihelion, the moment of closest solar contact, and then, like a trigger pulled, the explosion began. No existing comet model predicted that. Not the rate. Not the light curve. Not the chemistry. For an object that has traveled through interstellar darkness for billions of years, the precision of that response was unsettling. What mechanism could lie dormant for eons, then awaken in perfect synchronization with solar distance? What kind of material or design could remain intact long enough to still react this way? Those were the questions that began to ripple through observatories worldwide. Because in that moment, as 3I Atlas flashed brighter than any model allowed, scientists realized they weren't watching ordinary physics unfold. They were watching something new, and they didn't yet have a name for it. The first explanations came quickly and carefully. Maybe, scientists suggested, carbon dioxide was the culprit. Comets are layered like onions, ice over dust, dust over frozen gas. If a buried reservoir of CO2 had once sealed Atlas beneath a reflective frost, it could have acted like armor. As sunlight intensified, that layer might have finally cracked, exposing the volatile water ice beneath. It's a clean theory, simple, predictable. But the numbers refused to cooperate. The outburst wasn't gradual. It didn't follow the usual thermal curve. It was instantaneous, as though something had waited for a threshold and then reacted precisely when the temperature crossed it. That precision unnerved people. Then came the spectral anomalies. Atlas's light wasn't white or yellow like typical comets. It was blue, a hue that hinted at something far more complex than surface sublimation. Blue spectra meant carbon chains, imidazine molecules, molecular reactions at high temperature. Reactions that implied an interior, under pressure or structure. Computer simulations offered another possibility. Perhaps this wasn't just an icy rock, but a body encased in radiation-forged crust. Billions of years adrift in interstellar space would expose Atlas to galactic cosmic rays, high-energy particles capable of altering matter molecule by molecule. Over time, that relentless bombardment could transform soft ice into a dark, hardened shell, tens of feet thick, a shell that sealed the nucleus from further erosion. Then, as Atlas neared our sun for the first time, that crust finally fractured. The heat cracked the armor. The interior, untouched for eons, erupted into space. It's a convincing explanation, until you look closer, because such a crust, by accident, would be random and irregular. But Atlas's emission pattern wasn't random at all. It was even symmetrical, as if whatever broke through did so in harmony across its surface. That's what unsettled the researchers most. The eruption looked less like chaos and more like activation. Was it simply coincidence, a natural object performing an unnatural trick of timing? Or was something deeper at work, hidden beneath that irradiated armor? No one could yet say. But for the first time, the word design appeared quietly, hesitantly in scientific briefings. Not as belief, but as a question. And it would not be the last time that word was spoken. Within days of the outburst, every major observatory on Earth was watching 3I Atlas. But within weeks, Another pattern appeared, one not in the comet, but in the communication around it: silence. NASA's Solar and Heliospheric Observatory, SOHO, had captured the flare in stunning detail. So had its sister satellites, Stereo A and the new GOES-19, each equipped with coronagraphs, capable of imaging objects almost lost in the glare of the Sunday. They had the full story in pixels and spectra, high-resolution frames, thermal signatures, plasma interactions, everything scientists needed to understand what had happened. And yet, what reached the public was a trickle,
thermal signature
a
is
few
off the
low-resolution images,
We need
a brief
confirmation on
press
these
note,
readings
and
immediately.
nothing more. To the casual observer, it looked like bureaucracy. To the scientists who had been following Atlas for months, it felt like something else: hesitation. Requests for the raw data began to stack up. Teams from Japan, Belgium, Chile, and the U.S. asked for access to the unfiltered
Analysis
measurements.
is ongoing.
Most heard nothing back. Weeks passed. That's when Professor Avi Loeb decided to speak. The former chair of Harvard's astronomy department, Loeb had already built a reputation for asking questions most scientists avoided. Back in 2017, he had done the same when another interstellar object, Oumuamua, defied expectations. He had urged then,
We're running out of
as
time.
now,
I need those results now.
when data doesn't
Still
fit the
no
model,
response from the
fix
ethics
the model, not the data. Loeb published
Wait,
an
look at the
open
data.
letter
I think
addressed
we
to
have it.
NASA's Planetary Science Division. 3I Atlas, he wrote, is not just a comet. It is the third known interstellar visitor in human history. The measurements collected by our instruments are a global asset. They belong to every researcher, every citizen, and every student who looks up. Secrecy has no place in science. The letter ignited debate overnight. Some scientists supported him, arguing that withholding information undermined trust. Others accused him of sensationalism, claiming that premature release could mislead the public. But the question hanging in the air wasn't just about policy. It was about fear. What if the data, once seen in full, showed behavior no one could explain?
This is absurd.
Would releasing it
We
spark
should
understanding
focus on real
or panic?
science, not speculation.
Early fragments that were published only deepened the mystery. SOHO's images showed Atlas not as a compact nucleus with a bright dust tail, but as a stretched, ghostly smear glowing gas with almost no particulate matter, no rocky debris, no classic comet tail. Just a thin, elongated light, shimmering like a filament in the solar wind. Astronomers tried to interpret it. Some said the dust might be too fine to scatter visible light. Others proposed magnetic confinement or optical saturation. But the truth was simpler: they didn't know. And still, NASA stayed mostly quiet. Official statements referred vaguely to ongoing analysis and data calibration,
We are
to the scientific
in an
community.
ongoing data calibration
Those words felt hollow.
phase.
At conferences and online
We have a
forums,
problem with the
whispers
data.
began.
It doesn't match
Was
the
there
control
something
group.
in the reading, something
anyone finds
so
out, we're
anomalous
finished.
that it threatened
I know,
the
just
current
keep quiet for
cometary
now.
models? Were the instruments detecting electromagnetic emissions that didn't match known patterns? Was it simply too strange to explain without controversy? Loeb's response was steady, almost calm. If the data challenge our understanding, he said, then our understanding must change. The universe does not hide its truth. We do. It wasn't rebellion. It was a reminder that science loses its soul when it trades curiosity for caution. Because in the end, this wasn't just a story about one comet's outburst. It was about how humanity confronts the unknown, whether with open eyes or closed doors. 3I Atlas had
Signal
flared
fading
like a
rapidly.
signal across the void,
Confirmed.
and for a
All
moment,
tracking data
every
is
telescope on
terminating.
Earth turned toward it. But as the light began to fade, the real question remained: would we have the courage to face whatever that signal meant? While the debate over data raged on, a quieter revolution was unfolding in the background, one that reimagined what interstellar objects like Atlas truly are. Dr. Suzanne Falsner, an astrophysicist at the Forschungszentrum Jülich in Germany, was among the first to see the comet's outburst not as a problem, but as a clue. To her, 3I Atlas wasn't just a comet behaving badly. It was part of a larger story, the story of how planets are born, and sometimes how they fail to be. In a paper
aren't
that
debris.
circulated soon after the
They
Perihelion
aren't
event,
debris.
Falsner proposed something radical.
They
She
are
suggested
seeds.
that objects like Atlas might not be cosmic debris, but planetary embryos, seeds cast off from failed star systems, wandering the galaxy in exile. She called them interstellar nuclei of accretion INAs. Planet seeds. Her models showed that when a young star forms, it's surrounded by a swirling disk of dust and gas. In those turbulent environments, matter clumps together pebbles, into rocks. Rocks into boulders, until they either grow large enough to attract more mass, or get torn apart by collision and radiation. Most never make it. They die as dust before becoming worlds. But what if some escape? Falsner's simulations revealed that gravitational slingshots from giant planets, or even the chaotic birth of binary stars, could easily eject half-formed planetesimals into deep space. Once free, those bodies drift through the interstellar medium for billions of years, frozen and silent. And when they pass near another newborn star, they can be captured again, this time serving as ready-made cores for new planets to form around.
As you can see
It's a
visualized
simple,
here,
elegant solution to one of astronomy's oldest puzzles: how solid planets form so quickly in the short lifespans of protoplanetary disks. Falsner's theory suggests they don't start from scratch. They start from hand-me-downs from seeds like 3I Atlas. If that's true, then every interstellar object is more than just a wanderer. It's a survivor from a lineage older than our Sunday. Each one carries the chemistry, minerals, and isotopic fingerprints of the star it was born around a sample of alien geology drifting through the galaxy. It also means the Milky Way isn't a quiet void between systems. It's alive with motion, filled with planetary embryos, fragments, and seeds, billions of them endlessly migrating between stars. Falsner put it poetically in one interview: every comet that crosses our sky might be a ghost of a world that never formed a planet that almost was. 3I Atlas, she argued, could be one of those ghosts, a seed ejected from a long-dead star, wandering through space for 7 to 12 billion years, waiting for a second chance that never came. And now, by sheer coincidence or cosmic choreography, it has passed through our neighborhood, carrying in its irradiated crust the secrets of its birthplace. To look at it through a telescope, Falsner said, was to look back in time not just through the history of our solar system, but through the history of planetary creation itself. In that light, the brightening of Atlas wasn't destruction. It was revelation, a glimpse of what happens when a forgotten planet seed finally wakes, just for a moment, to remember the star it once knew. 3I Atlas wasn't the first messenger to enter our solar system from the dark between stars. In fact, it's the third and the most perplexing in a growing line of interstellar visitors that have rewritten our understanding of what exists beyond the sun's reach. The first was Oumuamua, discovered in October 2017 by a telescope in Hawaii. It entered our system from above the plane of the planets, moving too fast, too straight, and too clean to be native. At first, astronomers thought it was an asteroid. Then they realized it was something else entirely. Oumuamua had no tail, no gas emissions, no visible dust. And yet, as it left the sun's gravitational influence, it accelerated ever so slightly, but unmistakably, that shouldn't have happened.
It shouldn't
No
be
known
accelerating
natural
like
mechanism
that.
could account for it, at least not without releasing heat or vapor. Its shape didn't help either. Reflected light curves suggested an elongated, tumbling form, something like a cigar, or perhaps a thin sheet spinning as it traveled. Some speculated that solar radiation pressure could explain its movement, as if it were being pushed by sunlight like a sail. Others whispered different possibilities. One of those voices was Loeb. He argued, controversially, that the simplest explanation might not be a rock at all, but something made. A probe, a relic, a piece of technology from elsewhere, drifting silently through our cosmic neighborhood. The second visitor arrived 2 years later, 2I, Borisov, discovered by an amateur astronomer in Crimea. This one behaved more like a traditional comet, a bright nucleus, a tail of gas and dust, a predictable trajectory, but its chemistry was alien. Spectral readings showed ratios of cyanide and water that didn't match anything known from our solar system. Borisov was natural, yes, but foreign. Now, with Atlas, the pattern has become undeniable. 3 visitors, 3 anomalies, each telling a different story, each breaking a different rule. Oumuamua, no tail, but acceleration. Borisov, normal shape, but alien chemistry.
Or perhaps
Atlas
they're
brightening
fragments of a larger
explosively,
pattern.
but no dust at all. If you place them side by side, they form a progression, as though each new arrival were testing the boundaries of what we think interstellar objects should be. Perhaps they're just the random accidents of a chaotic galaxy. or perhaps they're fragments of a larger pattern we've only just begun to notice. Either way, they share one haunting detail. Each one came, passed through, and vanished. No repeats, no returns. They are travelers on trajectories so vast that we will never see them again. And for each one, we've had only weeks' brief flickers of data to record their presence before they disappear forever. If the universe does have a way of speaking to us, this is its language, one word at a time, one visitor at a time. Each whispering something we barely have time to understand before it's gone. As 3I Atlas rounded the sun and began its outbound journey, the mystery only deepened. By all logic, the comet's brightness should have stabilized, but the opposite happened. Its light curve, that simple graph of magnitude versus time, started to behave like a heartbeat. It pulsed. Observatories from Chile to Japan watched as its luminosity rose and dipped in irregular waves, like something alive trying to regulate its temperature. Yet, unlike living things, there was no visible mechanism, no jets, no rotation-induced flickers, no dust particles scattering sunlight. Instead, the space-based coronagraphs captured something profoundly strange. The comet appeared elongated, shimmering almost serpentine in the glare of the Sunday. A shape not consistent with a spherical nucleus, but a stretched body hundreds of meters long. And there was still no dust tail. Every other comet known to science grows one a stream of debris torn loose by solar heat. That dust is what makes comets visible to the naked eye, the glowing banners that streak across the night. But Atlas had none. It glowed purely from gas emissions, thin and spectral, a faint ribbon of ionized vapor without the glitter of solid particles. NASA's Stereo A satellite, designed to observe solar weather, recorded the anomaly from two separate angles. In both, the nucleus appeared too smooth, too uniform, as if its surface was fused rather than fragmented. That detail was easy to miss, but for comet scientists, it was a red flag. Nature rarely makes perfection. Then came the estimates of its mass, roughly 33 billion tons, making it heavier than Halley's comet, yet showing none of Halley's violent instability or chaotic spin. Atlas moved like a single, solid unit, steady, poised, unmoved by the usual gravitational tugs that deform other comets. Its trajectory added to the unease. It wasn't looping through the solar system like an arc. It was gliding straight through, following a nearly flat, linear path, the hallmark of something not born here. The angle of approach suggested it came from the direction of the galactic frontier, perhaps even beyond the thin disk of the Milky Way itself. When researchers fed its motion data into simulation models, they found a shocking result. Atlas had likely been traveling for 7 to 12 billion years. That's older than the Sunday, older than the Earth, older than our entire solar system. That means when our planet was still molten, when life was only a chemical dream, Atlas was already ancient, wandering between dying stars, its crust hardening under the fire of radiation. And yet, it survived. Not shattered, not eroded, not lost to gravitational chaos. It endured the long winter of interstellar space, its orbit unbroken, its identity intact. That alone defied probability. Objects that old simply don't last. They fragment, they vaporize, they disappear. Atlas had done none of these. Some scientists began to call it the survivor. Others called it the witness, because to still exist after 12 billion years means it's not just a remnant, it's a record. A living fossil from a time before our sun was even born. And yet, as beautiful as that idea is, it raises a darker thought. If time, radiation, and chaos couldn't destroy it, then perhaps it was never meant to be destroyed. Every generation of scientists eventually encounters a mystery that makes them uneasy, something that doesn't fit, that pushes the boundaries of what natural means. For ours, that mystery might be 3I Atlas. Its behavior, its structure, its precision, each defied randomness. The outburst at Perihelion didn't unfold gradually, like heat-driven sublimation should. It happened sharply, as if triggered. The blue light, the perfect symmetry, the absence of dust, all of it hinted at something orchestrated, not chaotic. And that word orchestrated is the one that scientists whisper but rarely write. To be clear, no one is claiming Atlas is artificial. There's no proof of that, no transmission, no pattern of signals, no geometry, impossible to nature. But every explanation so far demands an exception to the rules, and when the rules need too many exceptions, you must ask whether you're playing the wrong game. Let's entertain a thought experiment. If a civilization wanted to send something between stars not for centuries, but for billions of years, how would it survive? You wouldn't build it from metal. Metal corrodes, fractures, and erodes under constant radiation. You wouldn't make it shine. Reflective materials absorb too much energy. And you wouldn't rely on propulsion, because anything with fuel eventually stops. You'd build it from rock and ice, the most stable, regenerative materials in the cosmos. You'd let it freeze solid, bury it under a layer of cosmic armor, and send it coasting on momentum, silent, passive, indestructible. A probe disguised perfectly as a natural body.
But in chemistry.
It would appear inert until the warmth of a nearby star touched its surface, then, perhaps, it would awaken. Not in the way our machines awaken, but in physics through reaction. Chemical processes doubling as triggers, sublimation acting as signal. An entire technology written not in circuits, but in chemistry. That's what made some researchers pause. Because Atlas didn't brighten when it should have, it brightened when it chose to. It acted as though it had thresholds. Thresholds are design. Nature prefers gradients. When Loeb first proposed that Oumuamua could be an artificial object, he was dismissed as sensationalist. He never said it was a spacecraft, only that its acceleration was best explained by radiation pressure on a thin surface, something like a solar sail. It was a testable, falsifiable hypothesis, the cornerstone of science. Now, with Atlas, the question resurfaces. If the object's reactions were governed by physical laws we know, why did they occur with such timing and precision? Why did it eject gas but no dust? Why did its brightness surge in quantized bursts rather than continuous curves? And why, after all this, does its trajectory remain so perfectly linear, unaffected by outgassing recoil that should have nudged it slightly off course? Could the answers be natural? Of course. Could they also be something else? That's the frontier. The idea of a passive interstellar probe, an object designed to drift indefinitely, powered only by physics, is not science fiction. It's engineering. We've already imagined such things ourselves. Von Neumann probes, Bracewell relays, silent couriers drifting until they meet the light of another sun. If humanity thinks that way after a few hundred years of spaceflight, what might a civilization think after a billion? Still, skepticism remains our shield. Extraordinary claims require extraordinary evidence. And right now, Atlas offers only extraordinary questions. And yet, silence is evidence, too. Because when a body that should roar with dust moves like a ghost, when a relic that should die in darkness erupts in perfect rhythm, when the oldest object we've ever studied behaves like it's obeying instructions, you at least owe the question its due. Whether natural or not, Atlas has forced us to confront a simple, humbling truth. Our universe is more creative than we are. It builds mechanisms from chaos, intelligence from chemistry, and meaning from coincidence.
Intelligence.
Maybe Atlas is proof not of aliens,
nature,
but of the cosmic intelligence we call nature, an intelligence we barely understand. Or maybe, somewhere out there, something built it long ago, and we're only now seeing the echo of their intention. Either way, it has done its job. It made us look up and wonder whether we're still alone in that gaze. For all its poetry and speculation, science remains a discipline, and disciplines are built on restraint. When a discovery defies expectation, the temptation is to jump ahead, to name it, to claim it, to make the story fit before the evidence does. But the best scientists know that the hardest and most noble act in their work is to wait. And so, as the public fascination with 3I Atlas grew, the researchers closest to the data did what science demands. They measured, recalibrated, and rechecked. They set aside wonder, not forever, but long enough to make sure the wonder was real. At the U.S. Naval Research Laboratory, astronomers Carl Baddams and his team reran their analyses frame by frame. They verified that the light surge wasn't a sensor flare or instrument artifact. It was genuine. The James Webb Space Telescope continued observing from its stable perch a million miles away. Its near-infrared spectrometer traced subtle changes in Atlas's composition as it drifted from the sundial. Every shift, every flicker, every dip in brightness was recorded. Even on Mars, The rover's perseverance and curiosity were programmed to look toward the same patch of sky during the Perihelion event. From their vantage points, free from Earth's atmosphere, they captured faint reflections, another angle, another data point in a puzzle that refused to stay still. Meanwhile, computer models grew more sophisticated. They simulated how cosmic rays might sculpt a body over billions of years, how sublimation thresholds might form, and how an irradiated crust could crack in stages rather than all at once. Each model added a layer of understanding or confusion. No single explanation fit everything. And yet, that uncertainty was progress. Because uncertainty is the engine of science, the friction that keeps truth from slipping away too easily. Amid the public debate, Loeb continued his campaign for transparency. He wasn't demanding belief. He was demanding honesty.
Observe.
If the data support
Measure.
a natural explanation,
Test.
that will be beautiful, he said.
Fail.
If they don't,
Refine.
that will be beautiful too. Either way, we learn. That sentiment began to resonate. A growing number of astronomers signed open letters urging the release of all spectral and telemetry data on 3I Atlas. It wasn't rebellion, it was renewal. A return to the simple idea that discovery belongs to everyone. Because science doesn't thrive in silence. It thrives in the open air of skepticism and collaboration, where ideas compete and truth emerges in the struggle. One researcher described it perfectly. If we're going to understand the cosmos, we can't be afraid of our own curiosity. The scientific method doesn't ask for certainty. It asks for humility. You observe, you measure, you test, you fail, and in failing, you refine. You remove bias, strip away narrative, and let the evidence breathe. As the months passed, the data continued to pour in. Atlas's brightness began to level off, though not in the way predictions expected. Its outgassing decreased but irregularly. The curve looked less like a fading ember and more like a language we hadn't yet learned to read. To some, that was proof of complexity. To others, simply noise. Both possibilities are valid until they aren't.
Atlas
and
is
that's
still
the beauty of the
speaking.
scientific method. It makes room for both wonder and error, because both are necessary to reach truth. Whether Atlas is a natural comet shaped by cosmic time, or something that once carried intent, will not be decided by belief, but by patience, by light curves and spectra, not headlines and theories. In the end, science is not the opposite of mystery. It is the language through which mystery speaks slowly, precisely, one observation at a time. And 3I Atlas is still speaking. The question is whether we'll have the courage and the humility to keep listening. Now, the light fades. 3I Atlas, that pale traveler from the deep between stars, is slipping away. Each night, it grows fainter, retreating beyond the reach of telescopes, its trail dissolving into the dark. Soon, it will vanish completely, a memory of brightness swallowed by distance and time. But for a few weeks in the autumn of 2025, it was here close enough for us to see, to measure, to ask questions that echo louder than their answers. Whatever Atlas truly is, a comet, a planet seed, or something beyond our vocabulary, it has already changed us. Because it reminded us that the universe is not a silent void. It moves, it breathes, it surprises. Think about that. An object older than our sun, older than Earth itself, wandered across our
Leaving
sky
us
for a
with
moment
wonder.
and then disappeared, leaving us with wonder as its only residue. For the first time in human history, we are able to watch these visitors in real time. Our instruments can see beyond the glare of the sun, beyond the noise of distance, beyond the barrier that once kept our species blind to the movement of the cosmos. And what they reveal isn't chaos, it's conversation. The universe speaks in light and motion. It tells stories, written in the language of physics, the bending of trajectories, the pulse of brightness, the chemistry of ancient dust. We just have to learn how to listen. Perhaps 3I Atlas is entirely natural, a survivor of the universe's earliest dawn, carrying within it the frozen whispers of a forgotten star. Or perhaps it's something stranger, a vessel without crew, drifting from a civilization that ended before our world began. We may never know, and that's all right. Because the goal of science has never been certainty, only the courage to reach into the unknown and come back with something true. Loeb once said, "The universe is speaking. The question is not whether it's talking, it's whether we're listening." Maybe Atlas was never meant to answer us. Maybe its only purpose was to pass by, to make us look up again, to remind us that the story of life and intelligence and mystery didn't start with us and won't end with us. Somewhere out there, another traveler is already on its way. It might take years or centuries before it reaches our skies. But when it does, we'll be ready wiser, more curious, a little less certain, and a little more humble. Because that's what the cosmos teaches best. That we are part of something vast and beautiful, and that every visitor, natural or not, carries the same message. We are not alone in the wonder.